So today we're going to cover Chapter 7, Section 2. Today we're going to talk about properties of parallelograms. So first we're going to define what a parallelogram is. And a parallelogram is a quadrilateral with two pairs of parallel sides. To write the name of a parallelogram, you're either going to need to write out the word parallelogram and then put the four letters that are the four vertices of your parallelogram, or instead of having to write that long word, you can draw a picture of a parallelogram and then put the four vertices. So it looks like a little slanty rectangle, but you would draw a picture of a parallelogram and then you can indicate the four vertices. When you name it, you can start at any letter. It doesn't have to be alphabetical. So for example, this parallelogram that's pictured here, I could name it. Again, I would draw the picture of the parallelogram. And instead of going in alphabetical order, I could also go in reverse. Now you have to go and write the vertices consecutively. So I would have had to have written either A to B to C to D, going in that direction. Or I could have gone in reverse. And I could have also called it A, then the D, then the C, and then the B. So you have to go around the edges of the parallelogram and list it in order. Now you don't have to start with A. I could have also started with B. I could have said B, C, D, A, or even gone in reverse, B, A, D, C. Just pick a letter and start going around the edges in order. Yes?
So technically a parallelogram doesn't have to be slanted, right?
Correct. And that's what we're going to learn. We're going to learn that all rectangles are parallelograms. The only difference is the rectangle has four right angles. So what we're going to do is the general name for a four-sided figure is a quadrilateral. Then we're going to talk about parallelograms. Then after that, we're going to talk about rectangles and squares and rhombuses, which are all still parallelograms.
Yeah.
Okay, so this is where our sometimes, always, or nevers are going to come in this chapter, because I could state that all parallelograms are quadrilaterals because they're four sides, but you can't say that all quadrilaterals are parallelograms. Because trapezoids are not a parallelogram. So this is where the sometimes, always, or nevers are going to come in. So it might be a little bit tricky on your test. So just be careful. You need to know these properties very well for those questions. All right, so notice here, they've got the parallel indicators indicating that because by definition, a parallelogram has two pairs of parallel sides. So in my picture here, let me see if I can erase this. I can state, and notice the arrows here indicating that BC is parallel to AD, and that's what they had here, BC and then DA. And then this single arrow indicating that BA is parallel to CD. Okay, so that's just the definition, that a quadrilateral with two pairs of parallel sides is a parallelogram. Next, we're going to add some more properties, but they're going to be presented as theorems. Again, don't memorize the numbers. You can memorize the name. So the first one is the parallelogram opposite sides theorem. And this states that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So now, instead of just saying that AB is parallel to CD, now I can also say that AB is congruent to CD by the parallelogram opposite sides theorem. I can also say that BC and AD are parallel as well as congruent. And then we also have the parallelogram opposite angles theorem, and this states that if a quadrilateral is a parallelogram, then its opposite angles are congruent, and it's color coded here. So angle A is congruent to angle C, and angle B is congruent to angle D, and I know this because of the parallelogram opposite angles theorem. Some more properties, again, presented as theorems. Don't memorize the numbers. This one is called the parallelogram consecutive angles theorem. And this one states that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Now, we also, I guess, learned about consecutive angles. We were taught as the other name for them would be same side interior. So what we're really using here is our parallel sides. So AB parallel to CD. Think of AD as the transversal. And then you would say that A and D are supplements because they're consecutive interior angles, or also called same side interior. And you can keep going around the entire parallelogram, and all of the consecutive angles, meaning the angles that are right next to each other, are always going to be supplementary. So for example, and notice how it's color coded. So A and D are supplements because they're consecutive. They're one after the other. And then I could also say B and A are supplements because they're consecutive. And then I could go around this way and also say that B and C are supplements because they're consecutive. And then lastly, C and D. And that's what's all listed over here. So A plus B is equal to 180. The measure of B plus C equals 180. C plus D, and then D plus A. They're all supplements. We'll be using things like this in our proofs that we'll be writing in this chapter. We're going to be bringing back a lot of prior knowledge, all that alternate interior information, the consecutive interior information, in order to prove lines parallel. Then the last one here is the parallelogram diagonals theorem. And this one states that if a quadrilateral is a parallelogram, then its diagonals bisect each other. So what this means is if you're told it's a parallelogram, then I know that this diagonal here, BD, that's in blue, has been bisected. So BZ would be congruent to ZD or DZ, and that's what's written here. And then also diagonal AC is also been bisected. Now, these two diagonals are not congruent. We're going to learn coming up in another lesson that when the diagonals are congruent, it's actually a rectangle. But in a parallelogram, the diagonals do not necessarily need to be congruent. They're just bisected. So example 1, it says to name all pairs of parallel lines. Now, in order for us to even answer any of these questions, you must be given that ABCD is a parallelogram. If you're not given this, we can't answer any of these questions. So we have to be told that this picture down here is a parallelogram. Now, we just learned by definition that a parallelogram has two pairs of parallel sides. So I know that side BC is parallel to AD, and I'm going to go ahead and state that. BC parallel to AD. And then also the other pair, AB, is parallel to DC. And the order that you write the letters doesn't matter for segments. So those are your two pairs of parallel sides. Now, because they've drawn in the diagonals, we have quite a few pairs of congruent angles in this picture. So I'm going to start out by naming the ones we just learned about, and those are going to be the opposite angles. So I'm going to be using my the parallelogram opposite angles theorem. So I know that angle A here, and I need to name it with 3 letters. So this one right here is congruent to this one right here. So for part 2, by using my parallelogram opposite angles theorem, I can state that angle DAB is congruent to angle BCD. And then I can also state, or you could say it in reverse. You could have also said BAD is congruent to angle DCB. What's important here is that A and C are the middle letters. Okay, then the other pair would be this one, congruent to this one. So I could name that one as ABC is congruent to angle CDA. Or I could also say it in reverse. I could also say CBA congruent to angle ADC. Now that was what we just learned. Now also in this picture, because I have parallel sides, I also have a bunch of alternate interior angles. So what I can do here is show you the parallels. So I could state that AB is parallel to CD. And then what I can do is draw in my transversal. My first transversal could be BD. Making, and this picture is going to get really, really busy here because we've got lots of angles here. So I can show you that this angle here is congruent to this angle here because these are alternate interior angles. So, and then I also have another pair when I use the other transversal. So using alternate interior angles, I can go ahead and name these that I just listed here. And I can call this ABC. Let's see. So we're going to call it angle ABD. Sorry, ABD is congruent to angle CDB because it's alternate interior. Then what I can also do here is draw in the other transversal. So same parallel lines, but now let's say this transversal, let me do it in highlight, making this one. So now I have this angle that's formed. Let me get a different color here. So this angle, 2, 3, 1, 2, 3. So I can name this one as angle BAE or BAC, either way. I'm going to go all the way to the edge. And then also angle DCA. Now what I'm going to do is talk about the other pair of parallel sides, which are here. And now, still using the transversals again, now we've got another pair. So if I use this transversal, it's forming 1, 2, 3, 4. So this angle, and does the green show up? Yeah. So angle CBD is congruent to this one here, 1, 2, 3, 4, angle ADB. And then I also have the other transversal going this way now with those green lines. And then that's going to form 1, 2, oh, let me use a different color. I'll use black. then now 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So now I can call this one angle DAC. DAC is congruent to angle BCA. These are all my alternate interior pairs. And now I also have vertical angles that are surrounded in the middle. So this is where we're bringing back lots of prior knowledge in these parallelograms. All right, so I know it's really kind of crazy here. Let me go ahead and then we also have to do the congruent segments as well. So for the vertical angles, they're surrounding E here in the middle. And let's see if I have another color, maybe this orangish color. So I've got a pair here, and then here and here. So I've also got vertical angles that are congruent. And those vertical angles are either AEB is congruent to CED, and the other pair would be angle BEC congruent to DEA. Now I'm going to redraw the picture instead of trying to draw in the congruent segments. Yes. Uh-huh. All right, now for the congruent segments, what we have, and let me draw it over here to the side. Draw another parallelogram. So same one, let me just try to recreate it. Had the diagonals, and then it had E here. All right, so for the congruent segments now, we can show that opposite sides are congruent. So here I can say that AB is congruent to CD. I can also say that AD is congruent to BC. The order here doesn't matter, you can switch it up. And I also know that diagonals are bisected. So I know that BE is congruent to ED. And then I also know that this diagonal, 1, 2, 3, 4, AE would be congruent to EC. So these are the diagonals that were bisected. And then these are the opposite sides. So this is the parallelogram opposite side theorem. So lots of congruent pieces in this figure when you're told that this quadrilateral is a parallelogram. Pretty good. First example is good. So again, B is equal to 9, opposite sides are congruent, A is equal to 6, opposite angles, X is equal to 80 because it's opposite to the 80, and then these were same side interior or consecutive interior, and they were supplements. So really all you had to do was 180 minus 80, and you got 100 for the measure of angle Y. So for B, this one's got diagonals now, so it makes it a little bit more challenging. Now, first thing I can see is side A over here is congruent to this one. So side A is 12. For B, I know diagonals are bisected. So this little piece right here is 9. And then for angle Y, I know that these are parallel sides. This is my transversal. So I have a pair of alternate interior. So angle Y equals 45. And now X is referring to this whole angle here because it's got the little degree symbol. So what I can do is I know that these are same side interior. So what I can do is add X plus 35 plus 45, set that equal to 180. 35 plus 45 is 80. Subtract 80 from 180, and x equals 100. So x is 100 degrees. I found everything in that picture. A, B, X, Y. Let's try example C down there. So here, I've got some algebra to do now. So opposite sides are congruent. So I'm going to set 4x equal to 8, divide by 4, and x equals 2. And then same thing here, opposite sides are congruent. So for that one, 3y plus 4 equals 13. Subtract 4, 3y equals 9. Divide by 3, and y equals 3. No A and B on that picture. Example 3 says to find the perimeter of parallelogram PINE. Now, a picture was not provided, so I'm going to go ahead and draw one myself. So go in order. So P, I, N, E. It doesn't matter where you start, but just make sure that you go around it in order. So it says PI is 12 and IN is 8. I know from my theorems I just learned, or properties, that opposite sides are congruent. So I know this side over here will be 8. And if this one's 12, this one's also 12. So to find the perimeter, all I have to do is add up all the sides. 8 plus 8 plus 12 plus 12. Or you could do 2 times 8 plus 2 times 12. Either way, this gives me 40. So the perimeter of parallelogram PINE is 40. And there's no inches or units on this, so I could just describe it as 40 units. If they said that these were 12 and 8 inches, then the perimeter would just be 40 inches. And let's try a proof example. All right, try writing a 2-column proof. So let me go ahead and set up my statements in my reasons column. So again, I'm going to state all my given first. So I'm given that A, B, C, D, and G, D, E, F are, and I'm just going to draw the little picture of it, parallelograms. Or you could write out the word. That's given. So I know that I just learned 4 different theorems or 4 different properties about parallelograms. I'm going to be using those as my reasons in my proof. So what I'm going to state here is that angle B here is congruent to angle CDA. I have to name it with 3 letters. So I'm going to start out by saying, so I'm going to say angle CDA is congruent to angle B. And then the same thing in my other parallelogram, I could say that angle EDG is congruent to angle F. So I'm also going to say that angle EDG is congruent to angle F. And the reason why I can state that is because of the parallelogram opposite angles theorem. Now, if you didn't remember the name, also in here, you could have also just made the statement of what it says. And it says that if a quadrilateral is a parallelogram, then its opposite sides, angles are congruent. So if you forget the name, then you got to restate what the theorem says. Either one, you don't have to put both. What you could do is you could abbreviate it like do this, and then do opposite, and then angles. And then you don't have to write the word theorem. Be good? All right, so let's go. Now what we're going to also bring into the fact is, notice how I labeled these guys? I'm also going to say that these vertical angles are congruent. So I'm going to state that angle CDA is congruent to angle EDG. Now, if you would have preferred to stated that before and put that as step 2, you could. So you could interchange steps 2 and 3. So now that I've got, and notice I've already marked all the same markings, so now I can conclude that B is congruent to F, and my reason is substitution. Because if you notice up above here, CDA equals B and EDG equals F. So all you're doing is taking the F and putting it here, and then you're taking the B, which is equal to the CDA, and putting it here, and that's how you get that. So the last example, it says 3 vertices of parallelogram WXYZ are the following. It wants me to find the 4th coordinate to complete that parallelogram. So I'm going to go ahead and add in a graph. So I'm going to graph W. It's at -1, -3. I'm going to graph X, -3, +2. Then Z, +4, -4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so now once I've graphed them, I've started forming my parallelogram, I need to find the 4th coordinate. So what we're going to do is we need to find the slope, because remember we have parallel sides here, and we know that parallel lines have the same slope. So step number 1 would be to graph the vertices. So we're graphing W, X, and Z. Step number 2 is I'm going to find the slope of WX. So I'm going to go ahead and do the slope formula, y2 minus y1 over x2 minus x1. I'm going to subtract my order pairs, and I find the slope to be 5 over -2, which is -5/2. So now what I can do is, to get to my point, I'm going to move my rise and run. I'm going to rise 5 and run 2. So I'm going to start at point, I can start at point Z, and I'm going to go up 1, 2, 3, 4, 5. And then because it's negative, I'm going to run to the left. And then point Z is going to be located right here. And then I can connect and form my parallelogram. I'm sorry, that's not point Z, that's point Y. I moved from point Z. So my next step is going to be to start at Z, which was 4, -4. And then I'm going to move my rise and my run, the slope I just calculated. So I'm going to go 5 up, but because it's a negative slope, I'm going to go 2 to the left. And then that's going to give me point Y, which is the order pair 2, 1. Now, just to confirm, I could go back now, and I can also find the slopes of XY and WZ to see if they're going to be the same slopes. So if I quickly do the slope of XY, 1 minus 2, 2 minus -3, -1 over 5, which is -1/5. And then if I do the slope of WZ, -4 minus -3, 4 minus -1, which gives me -1/5. So because the slopes are equal, I did get the correct coordinate for y, and it's the ordered pair 2, 1. So because they're parallel, and I have 2 pairs of parallel sides, this is a parallelogram, and I did find point y correctly.